Hello, everyone. Thank you for taking the time to join us today. I'm Sri Chantala, a senior product manager here at Snowflake working on Cortex Analyst. In this session, we'll be discussing something very exciting, a new era of conversational self serve data analytics powered by generative AI. For today's session, here's what we'll cover. We'll kick it off with a brief introduction to Cortex Analyst. Next, we'll explore the key concepts and the importance of semantic models in generating highly accurate text to SQL. We'll also dive deeper into how everything works behind the scenes. I'll then share some exciting new feature enhancements we've recently added. And finally, we'll bring it all together with a demo. So let's jump right in. Before diving into Cortex Analyst, let's take a moment to reflect on the key problem we're aiming to solve. Empowering business users with direct data access traditionally has always been a challenge. These users have a deep understanding of the business, but writing SQL queries isn't typically part of their daily routine. Instead, they often rely on BI dashboards, which more often than not are either outdated or lack the flexibility they need. When they need specific data that these dashboards can't answer, they might turn to their data team colleagues, sending off an email or a Slack message with an ad hoc request. This approach, however, is slow and inefficient. For the data teams, this means not only managing complex dashboards, but also juggling a constant stream of ad hoc requests. And as most organizations have more business users than data engineers or analysts, this model simply does not scale. Large language models, or LLMs, have sparked a lot of interest lately, and for good reason. Their ability to understand natural language and generate code is opening up new possibilities, particularly when it comes to democratizing analytics and making it accessible to everyone and not just those who know how to write SQL. At Snowflake, we're particularly excited about the new feature we're calling Cortex Analyst. Announced at Summit and now in public preview, this feature is primarily geared towards empowering business and non technical users to self serve analytics and accelerate their ability to make data driven decisions. So, what is Cortex Analyst? Cortex Analyst is a fully managed service designed to enable developers and data teams to accelerate building of highly accurate and trusted conversational self-serve analytics applications for your end business users. This means business users can now directly interact with their structured data in Snowflake using natural language and without having to write any SQL. Let me walk you through the five key benefits of Cortex Analyst. First, it enables interactive self serve analytics via chat. Cortex Analyst is available as a convenient REST API, which can be integrated into any downstream chat interface. This means business users can get quick and reliable insights without needing technical expertise or waiting on data teams. Next, and perhaps most importantly, Cortex Analyst provides a highly accurate text to SQL service. This is not only essential, but the crux for building a trustworthy talk to your data solution. Powered by state of the art LLMs and a sophisticated agentic AI setup, Cortex Analyst ensures that text to SQL responses are highly accurate. It also leverages the concept of a semantic model, allowing data teams to fill in the missing semantic information that LLMs need to correctly answer business user questions. With this setup, Cortex Analyst is able to achieve over 90% SQL accuracy on real world business use cases. This is extremely important as trust and accuracy are paramount for any AI powered self serve analytics tools, as business users won't rely on a product that might provide inaccurate insights. Third, the service is exposed via convenient REST API, making it easy to integrate into any application, business tools, and platforms, bringing the power of data insights to where the business users already operate, such as Slack, Teams, Streamlit apps, custom chat interfaces, and more. Like all of Snowflake's features, Cortex Analyst prioritizes security and governance. We do not train on customer data, and for inference, Cortex Analyst generates SQL queries using the metadata provided in the semantic model and not the actual data. unless you explicitly opt in to allow the use of Azure OpenAI GPT models, Cortex Analyst is by default powered by Snowflake hosted Mistral and Meta models, ensuring no data leaves Snowflake's governance boundary. Additionally, Cortex Analyst is fully integrated with Snowflake's native privacy and governance RBAC features. And lastly, Cortex Analyst significantly outperforms DIY solutions. Building a highly accurate text to SQL solution from scratch is challenging, costly, and often fails to deliver the accuracy business users need. DIY approaches involve feeding raw schemas to LLMs, setting up complex RAG architectures, experimenting and fine tuning different models, and managing infrastructure. Additionally, developers have to juggle between balancing accuracy, latency, and costs, often yielding suboptimal solutions. Cortex Analyst eliminates all of these complexities and lowers the total cost of ownership by allowing data teams and developers to easily integrate it into applications via the REST API, ensuring the delivery of accurate text to SQL response that business users can trust. Apart from the sophisticated agentic AI setup, one of the key pillars for Cortex Analyst's high accuracy is the user provided semantic model, typically set up by someone on the data team. Let me explain why this is so important. You can think of an LLM alone like a super smart analyst who is new to your data organization. They lack the semantic context about the nuances of your data. Given only the raw schemas, it's challenging for any analyst to write SQL accurately to answer business users' data questions. This is because raw schemas are often messy and lack the semantic information needed for accurate data analysis. For instance, in a physical database, a column representing product categories might be abbreviated and labeled as CAT. However, a business user might refer to the same data as product category or product segment when asking a question. Without a semantic model to bridge this gap, LLMs struggle to recognize that these different terms all refer to the same piece of data, leading to potential inaccuracies in the analysis. In addition, physical data schemas tend to be comprehensive. For instance, a raw table may include multiple versions of sales numbers, while you only want to present one version to your end business users. A semantic model addresses all these issues by allowing the data team to do two things. One, specify additional semantic details about the dataset. This might include more descriptive names, synonyms, free-form descriptions of tables and columns, or even instructions on how certain data should be used. These details enable Cortex Analyst to bridge the gap between business users' vocabulary and the raw database schema, resulting in more accurate responses. Second, it also allows you to perform data modeling by exposing only the relevant columns and define common metrics and set filtering conditions. From our internal testing, we've seen that leveraging semantic models can nearly double the accuracy and precision of text to SQL responses. That's how crucial a well crafted semantic model is and the impact it can have on the accuracy of your solution. A key concept in Snowflake's semantic model is the logical table. You can think of a logical table as a simplified view over a physical database table or view. Each logical table is made up of logical columns which are categorized into dimensions, time dimensions, and measures. These logical columns can reference underlying physical columns or be SQL expressions involving one or multiple columns. You can also specify commonly used filters over the logical table, making it easier to apply consistent criteria across your analysis. Each of these categories allow you to define related fields like synonyms, descriptions, sample values, and more. This adds a layer of context that enhances the accuracy of your data analysis. Additionally, the semantic model can include verified queries, which improve accuracy and trustworthiness by providing a collection of predefined questions and corresponding SQL queries. Cortex Analyst can then leverage these queries when answering similar questions to further improve accuracy. The semantic model for Cortex Analyst is specified in a lightweight YAML format, making it both powerful and flexible for your data needs. Linked here are some resources to our open source tools to help you generate and iterate over your semantic models. It also provides a way to translate semantic data from popular third party tools like DBT or Looker into the format that Cortex Analyst supports. Cortex Analyst, combining the strength of state of the art LLMs from Mistral and Meta, along with user provided semantic models, achieves an impressive 90% plus SQL accuracy on real world use cases. The benchmark you see here was published as part of our public preview launch based on one of our internal eval set, which is representative of real world use cases. The results show that Cortex Analyst is consistently nearly twice as accurate as single shot SQL generation from leading LLMs. Additionally, it delivers approximately 14% better results compared to other solutions in the market. This slide summarizes the setup of Cortex Analyst. As we discussed, Cortex Analyst is a REST API that can power self service conversational apps such as a simple Streamlit chat app or a more sophisticated downstream custom app. It uses a semantic model set up by someone on the data team. Once everything is set up, business users can simply start asking questions in natural language through the conversational app. Cortex Analyst generates and returns the SQL query text, which can be executed in the background on the client side. This setup allows for easy customization, post processing of results, and presenting the data in a way that suits the preferences of the end business user, all without them needing to see or understand the SQL. In other words, the business user simply asks the data question in natural language and receive a direct answer, free from any technical barriers. Behind the scenes, answering users' data questions involves a comprehensive workflow that includes interacting between multiple LLM agents with guardrails at every step to prevent hallucinations and to deliver accurate and trustworthy answers. At a high level, when a business user asks a question, we first analyze the question intent to determine if it can be answered based on the underlying semantic data model. If the question is answerable, we generate and return the SQL query. If it is not, we explain why and suggest alternative questions the users can ask. To dive deeper, Cortex Analyst follows a series of steps to transform a natural language question into an accurate response. The client application sends a request to the Cortex Analyst REST API, including the user's question and the related semantic model YAML. A classification agent analyzes the intent of this question to determine if it can be answered. If the question is ambiguous or can't be answered confidently, we provide a list of similar confidently answerable questions. This way, the user isn't stuck and can still get reliable answers. If the question is deemed answerable, the feature extraction agent identifies specific features which influence behavior of downstream SQL generation agents. Then, a context enrichment agent enhances it with the semantics captured in the provided YAML file, which includes crucial information like names for measures and dimensions, columns, default aggregations, synonyms, descriptions, sample values, and more. The enriched context is then passed to multiple SQL generating agents, each using a different LLM. Different LLMs excel at various tasks. Some are better with time related concepts, while others handle complex aggregations more effectively. By using multiple LLMs, we enhance the accuracy and robustness of the generated SQL query. Next, an error correction agent checks the generated SQL for any syntactic or semantic errors using core Snowflake services like the SQL compiler. If errors are found, the agent runs a comprehensive loop to fix them. This step also addresses hallucinations, correcting instances where the model might invent entities outside the semantic data model or use non existing SQL functions. Finally, All the generated SQL queries are passed to a synthesizer agent. This agent synthesizes the work done by the previous agents to generate the final SQL query that most accurately answers the question at hand. The SQL query, along with the interpretation of the user's question, is included in the API response. The query can then be executed in the background of the client application, and the results are then presented to the end user. The diagram illustrates the flow, the sequence, and the interaction of the various agents we discussed in our previous slide. Since the public preview launch of Cortex Analyst, we added multiple enhancements, including support for star schema joins and multi-turn conversation, which are now in public preview. Additionally, we support integration with Cortex Search Service on your dimensions, enhancing literal usage in SQL queries. And finally, we have a Snowsite UI in the works that will allow you to create, iterate, and manage semantic models all in one place. So we're really excited to bring you all these new and exciting announcements. So give it a try, and we're really looking forward to hearing your feedback. All right, let's see Cortex Analyst and some of these new features in action. Here, I have a simple Streamlit and Snowflake chat app that serves as a conversational interface to Cortex Analyst. It's powered by a pre created semantic model file for the popular TPCH dataset. For those of you not familiar, the TPCH dataset is a benchmark used to simulate a large scale business scenario to model real world business processes in sales and supply chain contexts and serves as a great way to test real world BI questions end users might ask of applications powered by Cortex Analyst. Now, let's pretend that I'm an end user who knows nothing about the underlying data or what questions I can ask. I can simply start with, what questions can I ask? Cortex Analyst will then summarize the underlying semantic data model that powers the application. It informs the user that the model is designed to analyze various aspects of customer orders, supplier relationships, product details, and so forth. It also informs them that they can run detailed queries on customer demographics, order statuses, shipping instructions, part details, and more for comprehensive business insights. Additionally, it even suggests sample onboarding questions to help the user get started. I can either choose one of the suggested sample questions or ask my own. Let's go ahead and ask, what are the top 10 products generating the highest total revenue? As you can see, not only do we get the results, but if the user is interested, they can also view the SQL query that was used to generate the results. As you can see here, Cortex Analyst was able to join across the suppliers and parts tables to return the results. A key point to highlight here is that Cortex Analyst API returns only the SQL query text needed to answer the user's question. The logic for executing the SQL is handled by the client application layer, giving developers full control. They can post process the SQL, execute it in the background, and further refine the results to personalize them according to their business user preferences. For example, in the Streamlit app, I've added logic to take the results and display some simple line and bar charts. You could also implement more sophisticated features like using Cortex LLM functions to summarize the results and provide a natural language explanation to the end users if desired. Now, let's ask a follow up question. Which suppliers are providing these products? As you can see, it retains the context and provides details of the suppliers for the top 10 products. Another important thing I want to highlight is that Cortex Analyst always provides a question interpretation. This is incredibly helpful as it ensures that both the business user and the system are aligned on the meaning of the results, which is crucial when working with LLM powered solutions. Finally, just for fun, I'm going to ask a completely random question, like how many customers are on Mars? One of the biggest challenges with LLM powered solutions is the risk of hallucinations, where the system might generate non factual answers. However, with Cortex Analyst, we have guardrails at every step to ensure the system doesn't return inaccurate or misleading information. As you can see, it responds with an explanation of why it can't answer the question in its current form. It also provides prompts guiding the user to ask a more precise question, ensuring the users are never stuck. Now, let me walk you through the key components of the TPCH semantic demo YAML file, which is the heart of the demo we just saw. This file enables Cortex Analyst to accurately interpret and answer natural language questions. It's composed of several fields that help Cortex Analyst understand the specifics of your data, how it's structured, and how it should be interpreted. Let's start with the key components, logical tables and logical columns. Logical tables are the foundation of your semantic model. These correspond directly to the physical tables or views in your database. For example, in our file, we have 8 logical tables: customers, orders, line items, order line items, and so on, which correspond to the physical tables in the TPCH dataset. Additionally, each of these logical tables can be associated with logical columns, which are categorized into specific measures, dimensions, and time dimensions. This allows you to specify detailed and nuanced information about your underlying data. Logical columns add depth to your semantic model by referencing physical columns or defining expressions. These can either map directly to physical columns in your database or create new values through expressions. For example, the logical column line item quantity maps directly to the underlying physical column quantity. In contrast, the logical column net revenue is an expression that calculates the net extended price of the order line after discount but before tax. This column doesn't exist in the database and is derived on the fly. As you can see, we also have time dimensions, which are crucial for time series analysis. These capture the temporal aspects of your data, enabling queries involving time based trends and comparisons. For example, the line item ship date in the line item table and the order date in the orders table are the most frequently used time dimensions in the TPCH dataset. They allow you to track sales trends over time, analyze order volumes by date, examine shipping performances and delays. Now let's go over some key fields associated with these logical columns. The description field provides a clear explanation of what each measure, dimension, or time dimension represents. It can be added to tables, helping both users and the system understand the intent behind each object. For example, the line item extended price measure includes a description explaining that it represents the total price of the order line item for the full quantity before tax and discount. Next, the expression field, which defines what the logical column or measure represents. It either references the physical column, like line item discount, or be an expression that performs calculations on one or more columns. For example, as mentioned earlier, the expression for net revenue calculates the net extended price for the order line after discount but before tax. Then we have the synonyms field. This improves the system's ability to interpret natural language queries by offering alternative terms that business users might use. For example, gross revenue has synonyms like total price and revenue after tax. This allows users to ask questions using different terms while still receiving accurate results. The data type field defines the type of data in each column, such as number, varchar, or date, helping the system interpret and process the data correctly. The semantic model also supports defining sample values, primarily for dimensions to provide example values. This helps the system understand the range of possible values and improves the query interpretation. For example, the order priority dimension include sample values like urgent, high, and medium. While sample values are helpful, they may not be effective for dimensions with a large or constantly changing set of values. That's where Cortex Search comes in. For example, the part time dimension can have a large number of values. In this case, I can create a Cortex search service for this dimension, allowing the appropriate values to be retrieved at runtime. This improves the accuracy of SQL queries that uses literals. Next, we have the relationship section, which allows you to enable multi-table joins in Cortex Analyst by defining relationships between your logical tables. We currently support star schema joins and plan to expand further while maintaining high accuracy. Lastly, I want to highlight verified queries. The semantic model includes a section for adding prompts and corresponding SQL queries that have been pre validated for accuracy. These act as examples Cortex Analyst can reference, enhancing its ability to generate accurate responses to similar questions. This is especially useful for complex BI queries. Additionally, verified queries can be tagged as onboarding questions, allowing you to showcase helpful queries to your users, making it easier for them to get started with your conversational app. So, as you can see, semantic models provide a flexible and powerful way to capture detailed information about your data. By designing your semantic model effectively, you unlock the full potential of Cortex Analyst, enabling it to deliver precise and insightful answers to natural language queries from business users. We have open source tooling available as a Streamlit app and in SIS to help you easily generate and iterate on your semantic models. It includes a built in chat interface where you can ask questions, verify results, and refine your model for better performance. You can also test and add verified queries directly from the app. Plus, the tooling that support mapping popular third-party semantic layers into the format used by Cortex Analyst are also available. So give it a try. Looking ahead, we're working on direct integration into Snowsight UI for model creation and iteration, along with leveraging metadata and query history within Snowflake to auto-generate as much information as possible, making the process even more streamlined. Stay tuned for the private preview. Since its launch just a few months ago, we've already seen hundreds of customers use Cortex Analyst to empower their business users to become more data driven. Leading companies like Bayer, JPMC, among others, are leveraging Cortex Analyst as a query generation service, enhancing their existing business intelligence with self serve natural language analytics. Their end users range from VPs to sales teams, and even external customers are tapping into this tool to get faster and more insightful answers from their data. Here are some useful resources to get you started and learn more about Cortex Analyst and the other amazing Cortex GenAI services. Thank you all for tuning in. We hope you found this session helpful and can't wait to see the amazing ways you'll use Cortex Analyst. We're just getting started, so stay tuned and a lot more exciting stuff coming your way.